Welcome, and let's talk about solving equations with radicals involved, sometimes called radical equations or irrational equations. Now for starters, I want you to notice that I have a square root of 20 times the x. The x is not inside that radical. Some texts and some books will have a little sort of ending corner there, but most of the time people are just precise. So make sure when you're writing this, you don't have this like confusing approach where you're not sure if this x is halfway in the radical, which doesn't exist, or it's not, or it is. So sometimes it is really helpful to use this little sort of corner piece to indicate that I meant to put the x inside the radical here. I meant to put it outside here. So just a note on paying attention to details. So here, my recommendation to you is, hey, just like normal, we want to isolate x, so I'm going to divide by the square root of 20. You can't divide by an irrational. Well, I can, because I can later rationalize the denominator, so don't worry about it. My recommendation to you, though, is going to be to simplify first. Whenever solving equations, you want to simplify first, because then you might notice that you can combine some things. So look for simplifying first, and then maybe you can combine. And so root 20 is really a 2 root 5, and my root 5's cancel, and then I have negative 4 over 2, and so that equals a negative 2. And so negative 2 is my answer here. And if you think about it, if you go back and check, I would say root 20 is 2 root 5, multiply by my x, which is negative 2. Does that give me a negative 4 root 5? Yes, it does. All right. What's different about this one is that we have a variable inside our radical. So we can't hack into that radical sign around the a minus 3, so we've got to get rid of it somehow. So how would I take the square root of a minus 3? What would I have to multiply it by in order to just get maybe just plain a minus 3? Well, what would I have to multiply it by so the a minus 3 just pops out? Well, I'd have to multiply it by the square root of a minus 3. Okay, but if I do that to this side, then I'd have to do it to this side. But now I'm just going to have a problem over here, because the square root of a minus 3 is right over there. So you might be thinking, well, like, could we just square both sides? That's another way to get rid of that radical sign if I squared both sides. But hold on, if I'm squaring both sides, aren't I multiplying this side by a minus 3 and this side by 2 root 5? And I thought we had to multiply or divide or tack solve and do the same thing to both sides. Well, yeah, I do. These are the same thing, guys. My original equation told me this is exactly the same as this. So I'm actually totally legit and legal to square both sides because the equation told me they're the same thing. So squaring both sides is the key to getting rid of the radical. And then just make sure you multiply 2 root 5 times 2 root 5 properly. So you'd have 4 times a 5, so you get 20. Wow. A is 23. Yep, that was easy. Holy smokes. So these aren't so bad. Okay. So here's the one tricky part, though. Let's go over here. You are allowed to square both sides. That's cool. Please be careful and make sure you square both sides properly. X plus 3 squared is not x squared plus 9. Good heavens, no. Don't forget foiling. Don't forget your middle terms. Okay, don't forget your 6x. And then so my x squared plus 21 just pops right out. Cool, squaring both sides. All right, I'm going to set everything equal to 0. My x squareds are going to just go away. I'm going to subtract 21, so I'll have 6x. Let's see, why do I need to subtract 21? I don't need to do that. How about I just subtract 9? All right, I don't have to set everything equal to 0 because I thought it was a quadratic, but then my x squared's canceled. So 6x equals 21 minus 9, so that's 12, so x is equal to 2. And let's just check that under my handy dandy secret Answer, yeah. Now, probably be a good idea to go back and check this. So the square root of 4 plus 21, okay, that's the square root of 25, so that would give me 5. Is that equal to 2 plus 3? Yeah, 5 equals 5. Sweet. All right, so make a note. When you have the variable outside the radical, you probably just want to simplify and combine. When you have it inside, you're gonna most likely need to square both sides. Now, when you square both sides, that's a lot of power, so that brings a lot of responsibility. So you have to check your answers for something called extraneous roots, and I'll show you that here. Square root of 7 minus x equals x minus 5. We're going to square both sides to get rid of the radical and liberate the 7 minus x from the radical. I'm going to make sure I FOIL and do this binomial properly and get x squared minus 10x plus 25. I am going to have a quadratic, so I'm going to set everything equal to 0. I'm going to add x, and I'm going to subtract a 7. Yep, 25 minus 7 is 18. Okay, now I am going to have to factor this. So 18 is 9 and 2, 6 and 3. Ooh, okay, let's do a -6 and a -3. So my solutions are 3 and 6. Sweet, I'm so happy. I'm going to go get a treat from the fridge. You got to check for extraneous roots. So go back and check. Square root of 7 minus 3, is that the same thing as 3 minus 5? Okay, the square root of 4, is that the same thing as -2? Well, yeah, that's that tricky thing again. Well, I've been told that when the problem or the teacher gives me the square root, they're automatically assuming and saying, unless they write this, but they're automatically saying they want the positive root. So the square root of 4 is 2 because this radical sign was given to me by the problem. So no, that's not working, which means no, 3 is not an actual solution. Now let's check the other one. The square root of 7 minus 6 equals 6 minus 5. Yep, square root of 1 equals 1. Cool. All right, so there's actually only one solution here. 3 is an extraneous root. 6 is the solution to this problem. That's why you have to check. All right, careful. We've just been squaring both sides. I just want to remind you, these types of problems here, you do not need to square both sides. It would make it take forever, and you might have more extraneous roots. So just simplify first. So make sure you differentiate between, oh, wait, there's just a variable outside the radical versus, oh, yeah, there's a variable inside the radical. I do need to square both sides. So here is like my first problem, right? It's the same thing. Okay, we already did that one. But here, you might want to simplify first because I'm seeing a root 8. And you would divide both sides by -9 root 8. And go ahead and pause the video, practice, and get that answer. Welcome back. Your answer should be -1/18. All right. Just again a reminder, please be careful to square both sides properly. So, ooh, this is gonna be a trickier one. Okay. The left side will be x plus 5, but wait, this is gonna be weird. I'm gonna write this out just to make sure I do this right. Okay, so I have x plus a root x plus another root x plus 1. Okay, equals x plus 5. All right, I'm going to subtract x from both sides. See you later. I'm going to subtract 1. So I'll get 4 equals 2 root x. Huh. Okay. I could divide by 2, so 2 equals root x. So I'm already getting a sense for what my x will be equal to, but let me just do the motions of squaring both sides, so 4 equals x. Oh, cool. X equals 4. Let me go back up and double check that. So if x is 4, then this is the square root of 9. That gives me 3. If x is 4, this is 2 plus 1. Okay, cool. So yeah, x is 4. All right, so just make sure you are not forgetting about your middle terms. All right, cube roots, those are interesting. Let's just take a quick gander at this. Huh. All right, my x is outside of the radical, so I'm going to look into simplifying first. And I have an 8 hiding in here, so this will be 2 cube root of 3x plus the cube root of 6. I'm going to subtract my 2 cube root of 3x, and so I will have, oops, this was a 2. So I have a cube root of 3x minus a 2 cube root of 3x, so I'll get a negative cube root of 3x equals a cube root of 6. Great. I'm going to divide by a negative cube root of 3, divide by a negative cube root of 3. So this is the same thing as the cube root of 6 over 3, so negative cube root of 2. Cool. I'm okay with that. And there's my answer. Cool. Negative cube root of 2. Sweet. All right, that's our intro to irrational